Welcome to 7.4 Inverse Functions. So, Chapter 7 is just going to continue to talk about all sorts of different types of functions or not functions for the rest of this chapter, 7.4, 7.5, and 7.6. And today we're talking about something called an inverse. So, you should know an inverse, the official definition is that it maps the output values, which are the y's, back to the input values. So it maps the output values back to the input values. So let me tell you, my Miss Olson specialty unofficial definition is the x's become the y's and the y's become the x's. So that's what's happening. An inverse is where the x's and y's switch places, basically. So let's suppose that I had a relation. We don't know yet if it's a function, so relation is just a term to mean any set of ordered pairs. So here's my relation. And while I give you these pairs, we're going to go ahead and graph it at this graph right over here. So the first order pair is -2, 4. There it is, -2, 4. Next, -1, 2. Alright, next, 0, 0. There it is. Alright, next, 1, -2. And last but not least, 2, -4. Alright, there it is. Now, to make our inverse relation, when I say the x's and y's switch, literally, the x's and y's switch. So everything that was a y is now an x, and everything that was a x is now a y. And now I'm going to graph our new relation we made, the inverse relation, and then I'll show you kind of like how the graphs are related. So I'm going to go through and graph these points. So 4, -2. Alright, there it is. 2, -1, 0, 0. Okay. -2, 1, and -4, 2. Alright, there's our graph. So you may not be able to recognize this pattern because you haven't been working with this a lot yet, but what's happening is that the graph of the inverse, and this goes for any inverse I graph, the inverse of the graph is always reflected across the line y equals x. And the line y equals x, if you think of it as like y equals 1x plus 0. So it starts at 0, 0 for the y-intercept, and it has a slope of 1. So this is my line y equals x. And if you look at what happened here, these points, if I took a piece of paper and if I folded it in half along that line, these points would match up. Do you see what I'm saying? So all of these points, the ones that match, so like that one matches with that one, if I folded it in half along that line, they would match up. So that's one way you can kind of eyeball something to see if it's a function or not. And if I had some paper, maybe we'll show you in class some examples. I don't know. We'll see if we have time. Alright, so that's what it looks like as a graph. Now I want to show you some notation of inverses. So you should know inverses are notated by a -1. So let's say I wanted to find the inverse of f of x. The inverse of f of x is notated by f -1x. So I agree with you. Doesn't it look like it's f to the -1 exponent? It's not, though. That's the way they say f inverse. So this you would read f inverse of x. And sometimes I don't even put the x. Sometimes I just put f to the -1. That means we're finding the inverse. I just showed you a second ago how to find the inverse with ordered pairs, and that's something you will have to be doing on your assignment. We're also going to find the inverse just algebraically. And there's a special process to this that you have learned before, so this is review. But to find the inverse, remember how I said we're switching x and y? That's our first step. So to find an inverse of something, we're going to switch x and y. And then step 2, we're going to solve for y. Quick side note, sometimes they say f of x to start off with, though. So sometimes you're going to switch y and f of x, and I'm going to say more about that on the back page, because f of x equals y from what we learned the other day. All right, so let's go through it. Step 1, and for example 1a, switch x and y. Cool. Step 2, I'm going to solve for y. That means my final goal is to get y all by itself. So when I look at this, normal equation solving. Add 4 to both sides. You usually want to add or subtract first. And then to get rid of the 2, I'll divide by 2. And if you wrote it like that, that would be okay. And I believe the back of the book, honestly, is going to split this up. So they're going to, instead of dividing it all at once, they're going to divide the x and the 4 at a separate time and end up with x over 2 plus 2. So if you're trying to check your answer in the back of the book, I'd recommend you do this just so that it matches. But there we are. Go ahead and pause and try part B. Okay, if you have unpaused it, I'm just going to do this one pretty fast, so make sure you pause the video if you need to go a little slower. That's fine. But I'm doing this fast because I want to check your work. All right, this time to get rid of the negative 1/3, I'm going to multiply by the reciprocal. And remember, when I do that, I got to do it to both pieces. So I end up with negative 3x plus 6 for my inverse this time. Another thing we're going to do with this is we are going to do verifying if two things are inverses. So what they're going to do with this type of problem is they're going to give you two different functions, and they're going to say verify that if they're inverses or not. So our answer is going to be a yes or no, and we can tell if it's yes or no because I'm going to tell you that two functions are inverses if, and here's where the composition of functions from 7.3 comes in, if f of g of x is equal to x and g of f of x is equal to x, and it will be equal to x each time. So if both of those are true, then yes, they're inverses. If both of those are not true, then they're not inverses. And when you do this during assignment time, you have to show your work to verify this. You can't just say yes or no. So you're being graded on your work you show to verify. So here's what I'm going to do then. First, I'm going to find f of the f inverse. Then I'm going to find f inverse of the f. So I'm going to just take turns plugging these into each other. Alright, so this is going to be a little confusing, so watch closely. The inverse is 1/2 x plus 2, so that's what's going on in my mind. And then remember, you write down the function we're using, so this time f is on the outside, so I'm using this function, 2x minus 4. I left a little blank for x because remember, that's where now I erase and plug in what I wanted to change it to, which is what's in this parentheses. And now I'm going to simplify. So distribute the 2. 2 times 1/2 is 1. 2 times 2 is 4. Wow, 4 minus 4 is x. Check, that side worked. Now we need to do the other side. So again, I would recommend write down the function you're going to plug in. So f of x, this time I'm going the other way. This time I'm going to plug in 2x minus 4, and f of negative 1 is what I'm plugging it into. So f of negative 1 looks like this. It's 1/2 x, only I replace the x with a parentheses. And then I'm going to stick 2x minus 4 right in there. Alright, distribute. 1/2 times 2 is 1. 1/2 times negative 4 is negative 2. And it ends up being an answer of x again. So, yes, these are inverses. If you feel like you need extra practice, pause the video and try part B. Okay, if you have unpaused, I'm going to go through this one a little quicker, but you can ask some questions to clarify during class later tomorrow if you need it. Okay, so again, I got to test it both ways. So first I'm plugging in the F inverse into F, and then I'm going to plug F into F inverse. Wow, confusing. Okay, so first I'm plugging in F inverse into F. So I'll write that in the parentheses. And then the outside function is F. So that's what I write down. Where X was, I leave a space. And that's where I plug in this part of it. So I plugged one function right into the other one, right where X was. Now I'm going to simplify. So distribute. -3 times -1/3 is +1. -3 times 2 is -6. And keep going. -6 plus 6 is 0. Check. And now going the other way. This time, I want to plug F in. So F is -3x plus 6. And this time F inverse is on the outside, so I'm going to write down my F inverse, and again, instead of x, put a parentheses, and then I'm going to put in what I'm plugging in right into the parentheses, and then I'm going to simplify. So distribute, -1/3 times -3 is 1, -1/3 times 6 is -2, -2 plus 2 is just x. So check again, yes, they are inverses. This is the end of part 1 for 7-4.